Okay, so let's look at number 61, and there may be different ways of that you've seen to do this or thought to do this, and this is what I recommend. This is going to be the easiest, safest thing to do. Um, so we have cosine of x over 4 is equal to 0. If I'm finding all real solutions, which you were for homework, this is how I'd work it, which is a little bit different than if I said find all solutions on 0 to 2 pi. So I'm also going to do both of these things on these problems, okay? What I would do first is say cosine u equals 0. I would do u sub for sure. I don't want to sit around and try to think of all the angles I can that I divide by 4 and then get 0, okay? So I'm going to make my life a lot easier and knock it down to when we first started trigonometry. And I've got to know everywhere cosine is 0, which is at pi over 2 and 3 pi over 2. And I would go in and add the period plus 2 pi k as if you were working this problem. Sine and cosine's period is 2 pi. I would do it right now, and I'll tell you why. Okay? And you don't have to, so we'll talk about that some more in just a minute. All right, now I just solved that for you, but I'm going to take u back out and put in x over 4. So now how do you solve for x at the end of the problem? What are you going to have to do to solve for x? Multiply by 4. So if you multiply this by 4, you're going to get 2 pi. And you multiply this by 4, you're going to get 12 pi. And you multiply this by 4, you're going to get 8 pi k. Which is that's an acceptable answer. Now look at what happens. There's other answers I'll accept, and we'll talk about that in just a minute. Okay, so anyway, what just happened is I go ahead and treat it like an old problem. And then when I multiplied each one of these by 4, what it did was it took this graph that I'm used to looking at, and when I multiplied it by 4, it stretched it all out to the correct period, which I think is at the very end of the last class. But if I go ahead and say plus 2 pi k, or whatever the period of the graph is, and then I multiply it all the way through, y'all see it stretched it out to the actual period of that cosine of x over 4 graph. So that is acceptable. You can do that. There's other answers that are also acceptable. But that one's fine. Katie?
Would it be 6 pi? Or did I do? Well, I did 6 pi. I got 6. Oh, because it's 4. I got 3.
Oh, I should have 6.
It's
Oh, sorry. Thanks. Thank you, Katie. Let me click undo.
Can't you just add the period to because it says 0 on the axes? So you just be able to add the period to keep going down.
Wait. I just want to see what my mistake. Oh, I made my mistake here. Is this what you were saying?
Yeah.
Okay, I'm so sorry. Multiply by 4. Thanks, Katie. That would give you 2 pi over 2. Multiply by 4. That would give you 12 pi, and then I didn't divide by 2. So that should give you 6 pi.
Can you just take away the 2 pi's, add 4 pi k?
You could, if you notice this, you could just do it this way. 2 pi plus 4 pi k. And so what, was that your voice, Rebecca?
Yeah.
Okay. So you have 2 pi as answers 4 pi. 2 pi, 6 pi, and every 8 pi k. That carries this one to 10. That carries this one when I add 8 to 14. When I add 8 to this one, that carries it to 18. And when I add 8 to this one, it carries it to 22. So if you look at what Rebecca said, you could also pick these up as you go. Okay? If you notice that. And the back of the book had the this answer right here. I think a lot of students would have this answer if they had worked it without the back of the book. But surely be on the lookout for something that maybe you could shorten, make it a more concise answer. All right, any questions on that? So what just happened is this. I treated it just like a regular cosine graph. And then when I multiplied everything by 4, it stretched it out. Do y'all see what I mean? And taken all of the numbers, stretched them all out as it should. Okay, so let's move on. Sounds like everybody's okay with that. Oh, let me do it. Now we've got to have a bigger discussion about this over here. So sorry about my voice. All right, what if I'd asked you for just the answers from 0 to 2 pi, okay? Which happens sometimes, and Mr. Hill and I might put that on the test. We usually do. And I'll look for some more practice on these. I would still go cosine u is equal to 0. And I would start listing what would make it 0, which is pi over 2, 3 pi over 2. And you can keep listing them because you're trying to see how many that you need. I'm going to stop there for just a minute. The reason I'm going to stop there is I realize the period of this graph is 2 pi over 1/4, or 8 pi. And I'll come back to this after I get another problem done. But if I take u back out and put x over 4 in and solve for x, I'll get 2 pi and 6 pi. And I could get more and more and more, like we said, 10 pi and so on. But if I just want the answers from 0 to 2 pi, this would be the only one. Also, there might be no answer if your domain was written like this. From 0 to 2 pi inclusive, I might not get any answers from 0 to 2 pi. This graph takes so long to finish that you might not have anything happen. Do y'all see what I mean, the difference in the bracket and the parentheses? Okay, we'll come back to this problem in a minute. All right, now let's go to 62. Like I said, I was going to thread these in. You may not have tried 62. 62 is the sine of x over 2 equals 0. All right, the sine of x over 2 equals 0. I'm going to treat this as the sine of u equals 0. And sine is 0 at 0, pi, 2 pi, and so on. I'm not going to list 2 pi. Why not?
Because that's 0.
Right. There are going to be times that I might list that, and I'll talk about that again in just a minute. Like Nicole said, if I go 0, pi, 2 pi, 3 pi, those are just coterminal with what I already have. And if you're finding all real solutions, you just need everything the first time it goes through, and then add the period to it. All right, so I'm going to have u is equal to that. I'm going to take u out and put in x over 2. Oh, I'm sorry. I would go in and add the period to this. The period of sine is 2 pi. Then I'm going to put x over 2 in for u, because it was just a temporary fix. And when I multiply by 2, I get 0, 2 pi, plus 4 pi k. And obviously we should say where k is any integer. Now if I list those out, similar to what Rebecca said earlier, sorry, I need some Kleenex and some water. I saw Kleenex somewhere.
Right here.
Okay. You might notice this, and we'll talk about how you might notice this anyway, because you might be sitting there looking at me going, well, how would I have known that would happen? If I add 4 pi to these two, if I add 4 pi to this one, I get 4 pi. If I add 4 pi to this one, I get 6 pi. If I add 4 pi to this one, I get 8 pi. If I add 4 pi to this one, I get 10 pi. So is there a little bit more concise way to say my answer?
0 plus 2 plus 2 pi k.
Or you could just say 2 pi k, where k is any integer. Because k could also be 0. I wouldn't count off if you said 0 plus 2 pi k, but what's 0 plus 2 pi k? It's 2 pi k. But I would know what you were thinking. You were just probably starting your count by then. How would I know that to kind of even look out for that? Is here's 0 and here's pi. Do you see how they're exactly 180 degrees apart? A lot of times when you land on something that is just halfway or all the way around, this repetitive stuff happens. Okay? Hang on just a second. And I'll get to you. I would take this answer or this answer. Sorry. I would take this answer or this answer. Technically, you don't need that 0 in there, like we said. You could just say 2 pi plus 4 pi k. Or could you? No, you need the 0 in there. You couldn't there. So I would take either one of those answers. Maybe some others, okay?
So like the way that we do it, like you only account for like the positive side of it, but like why don't you do like plus
K
or
is, because K, you should write where K is any integer.
oh, so k
Can be negative. So I'm going back this way and this way
okay,
and that way. It'll take you like forwards on the calendar and backwards on the calendar. Good question. Yeah, I tend to go in the positive direction, but you don't have to. You could even say pi k, where k is any what?
Any integer times pi. Oh wait, any integer times 2.
I think maybe. I was thinking any even integer. So let's name the even numbers. 0 is also an integer, right? So do we have 0 pi, 2 pi, 4 pi, 6 pi, 8 pi? Negative 2 pi? So do you see that's a time where I might grade someone's paper and take that? That's why it's so important you define what k is. If you just said pi k, I don't know what you're talking about. You've got to tell me what your k is. All right? Lindsay?
In the first one that you circled though, like the 0, 2 pi plus 4 pi k can be any.
Those two are k is any integer. On this one and this one is where k is any integer.
And like on a test, you only need to have that once, right? Like if you just write like k.
Yeah, and you know, you can give me an asterisk if you change your mind.
Okay.
Yeah, what Nicole's talking about is, I told y'all some of my students at the top of the page write k is meant to be any integer, so you don't have to write it at every problem. Just be careful in case you change your mind and want to do something cuter. You can make sure you make a note of it, okay? You could say unless otherwise specified, k is any integer. All right, it is important to define k. All right, now let's do only the solutions from 0 to 2 pi, which is asked for a lot in AP Calculus. So suppose that you see this on the test, and usually 0 is included and 2 pi is not. Kind of like, I really didn't mean to be tricky on the quiz, but when you land on 2 pi, you're really starting over again. You're at 0. All right, so I'm going to say u is 0, pi, 2 pi, 3 pi, and Nicole, I could also do the negatives, but I know I don't need to do that here because I'm only going from 0 to 2 pi.
Mm-hmm.
Then when I take u back out, and pause for a minute as you're watching me do this, I listed a bunch of them because I'm not really sure how many of them I need yet. I want to make sure I catch everything between 0 and 2 pi. When I multiply by 4, I get 0. Oh, goodness. Probably shouldn't have come to work today. So anyway. When I multiply by 2, I was going to give you all my excuses, but excuses don't matter. when you multiply by 2, you get 0, 2 pi, 4 pi, 6 pi. Y'all keep correcting me because I may make a lot of mistakes. All right, that goes on and on in both directions forever. I want only the ones from 0 to 2 pi, so your only answer here would be 0. The reason that that is true is the period of this graph, if I ask it on a quiz, would be 4 pi. A sine graph looks like this. And so by the time you get halfway through, you're at 2 pi. And the only time it equaled 0 was right here at the beginning, because I didn't include 2 pi on that. So if I ask you this, you may have thought that was going to be a little easier, sometimes kind of harder. You've got to be really aware of what your graph is doing. Right now, we're about to look at some graphs that are spinning fast that have a really high frequency, like they're squished in. The first two we've done today are real long frequencies. So between 0 and 2 pi, they just don't have many answers, as opposed to watch this. Do you see the difference if you have a high frequency graph that has a very short period? You might have a lot of answers between 0 and 2 pi. And we're going to talk about how to find those. All right, so let's go to 63. And it's going to happen on 63. All right, on 63, I have sine of 4x equals 1. All right, so I'm going to say sine of u equals 1. Always tell somebody what you're doing. Get used to that as you head toward AP. The only time I can think of one time around is pi over 2. Because what happens down at 270, at 3 pi over 2, it's negative 1. Okay? So it only happens one time around. Or if you're looking at the stretched out sine wave in one period, it only hits one time, doesn't it? Some things it hits more than once. All right, so I'm going to say plus 2 pi k, treating it like the easy period that we had, the very first thing we ever saw. Then I'm going to take u out and put 4x in. So now I'm going to have to divide by 4. Girls, watch my hands, or we'll just do this. If I divide by 4, I don't know if it's going to let me do it. Oh, there we go. Do you see if I divide by 4, it squishes it in like this? Okay? So I'm going to divide everything by 4. That'll give me pi over 8. And if I divide this by 4, that's going to give me pi over 2k. I'm just looking to see which I think is exactly what they had in the back of the book for you. Students at this point usually want to start asking me, like, well, I always have one answer. Well, I always have 2 answers. Well, you could have 8 answers. Or you could have no answers. There's not any kind of rule. You have to just really know what you're doing. Okay? All right, now, what are you doing? I want to reiterate this. When you say this, where k is any integer, you're saying somebody could pick this up and type into their calculator the sine of pi over 8 plus pi over 2 times 785. And when they push enter, they'll get 1. Do y'all see what I'm talking about? You're telling them every time it's going to hit that 1, backwards and forwards. All right, now what if I'd said 0 to 2 pi? This is what I've kind of been waiting to get to here. Usually the 0's included and the 2 pi's not. Again, this is very common on the AP exam for them just to give you a shortened domain. I would treat it the same way. Sine of u is 1. I would list a few. Pi over 2. 5 pi over 2 is the next one. Are y'all okay with that? You might know it the next time it's going to hit it. This is pi over 2. This is 3 pi over 2. That's how I knew that one was 5 pi over 2. So this one's 7 pi over 2. So what's this one way up here? 9 pi over 2. Huh? Right now we are. Thank you. And then this one's 11 pi over 2. So what's this one? 12 pi over 2? I'm sorry. 12's over here. 13 pi over 2. Okay? These are all pi apart right here. All right, now Lindsay's already noticed that I've gone too far, but I'm about to take u out and put what back in? 4x. So I'm going to divide them all by 4 now, and I get pi over 8, 5 pi over 8, or multiplying by 1/4. Are y'all okay with that? 9 pi over 8, and 13 pi over 8. So that's why I said, wait a second, Lindsay, okay? Did those all land between 0 and 2 pi?
Yeah.
They did, didn't they? What's 2 pi over, if you're using 8s? Wouldn't 2 pi be 16 pi over 8? All right, so what just happened that I knew ahead of time, but I had to go ahead and get that out there, is see this 4 right here? That means if I'm doing 0 to 2 pi, I better go out 4 cycles. 1, 2, 3, 4, because it has such a high frequency. By the time I get out to 2 pi, it will have gone through 4 complete rotations. So if this says 4x and I have a limited domain, I'll go out 4 times and watch this. When I divide by 4, doesn't it squish it all back down? Okay? So if that says 3x, I would suggest you wrap around 3 times with all of your answers and then divide them all by 3 and you'll catch every single one of them. So from this really kind of crummy picture here, do you see that there should be how many times it equals 1 between 0 and 2 pi? Did y'all see that? Okay, so I know that I kept saying I was going to go back to those other problems. Now let's look back. I think I erased one of them, so we'll look back at this one. Why didn't I wrap around and around and around on this problem? Because I knew it had what we call a very low frequency. The period of that was 8 pi. Are y'all okay with that? So 2 pi over 1/4. The period of that one is 8 pi. So I knew I didn't have to like wrap around and around. Not much was going to happen from 0 to 2 pi. Here's kind of your safety net. You could write a few out, and then when you divide or multiply by the appropriate number, if they don't fit in 0 to 2 pi, just scratch them out. It doesn't hurt to think about them. You just want to make sure you get as many as you can. You can always scratch out extras. Does that make sense? Y'all look okay with this. Let's keep going. Okay? So now we're back to homework problem number 65. All right, on 65, we have sine 2x equals negative square root of 3 over 2, which is why you're doing your memo quizzes. You should recognize that and know where that happens. That happens, oh, well, first of all, I'm going to go sine of u is negative root 3 over 2. That calls to mind 60-degree angles that are here and here. I'm going to stay in radians. You could do this in degrees, but I'm going to stay in radians. So I'm going to say that happens when u is 4 pi over 3 and 5 pi over 3. I'm going to treat it like a normal sine wave and say plus 2 pi k. I'm just going to do the whole thing as if it was just an easy graph and it's going to repeat itself every 2 pi. Then I'm going to take u out and put in 2x. And then when I divide by 2, I get 4 pi over 6, 5 pi over 6, plus pi k, where k is any integer. And sure, you might want to call this one 2 pi over 3. Question?
This might be a little specific, but is it acceptable if we put our answer with just the pi plus pi k or plus 2 pi k at the end without like parentheses or anything? Because it looks like the pi k is just for the pi, 5 pi over 2.
Yeah, it's technically,
Should you put
that
the pi
technically
k
is mathematically incorrect. We write them like that a lot. But I really shouldn't. I probably should do something like this. But still, addition isn't distributive. So that still doesn't quite cut it.
Could I put like 4
So
pi
you-
over
I-
6 plus pi k and then comma 5 over?
I really should write them down twice. Zaina, I really should be going 2 pi over 3 plus pi k, and 5 pi over 6 plus pi k, where k is any integer. Because right now it just looks like I'm adding it to the 5 pi over 6. I don't remember how they write it for you. They write it twice. Hey girls, what I circled there, do y'all see what Zayna was asking me? Okay. You can write it like this on the test. I write like this all the time. But to be really clear, that's a whole lot better. Okay? It's a great discussion. All right, now let's take it from 0 to 2 pi. All right, I'm going to say u is 4 pi over 3 and 5 pi over 3. Looking at where sine of u is negative square root of 3 over 2. All right, but do y'all see this 2x, girls? That means this thing's spinning double time. It's spinning faster, so I should at least go around twice. So how do you go around again? This was at the very end of the last class. To go around again, the easiest way to do it is just to add 2 pi to whatever you have. Think in degrees. Wouldn't you add 360 to, quote, go around again? All right, so after all your graphing, I know that you can add by 2 pi. So 2 pi is 6 pi over 3. So this one takes me to 10 pi over 3 and 11 pi over 3, which, as Lindsay noted last time, that's past 2 pi. But I'm not finished. I'm going to take u back out and put 2x in. So what I did with 10 pi over 3 and 11 pi over 3 is I added just one more rotation to it. I went out 2 cycles. And then I'm going to divide them all by 2. And when I divide the first one by 2, I technically get 2 pi over 3, 5 pi over 6. I think this one would be 5 pi over 3, and 11 pi over 6. And they all squeezed in between 0 and 2 pi. So the big lesson I wanted to talk to you about today is if it's x over something, like x over 2 or 3, there's not going to be many, if any, answers between 0 and 2 pi because it's so long and stretched out. If you have a 3x or a 2x, you go out that many more cycles and then divide it and it squishes it back down. When you're finding all real solutions, y'all see there's no point in going out another one and another one because you're going to go out another one and another one. I mean, you're going everywhere anyway. So just find one cycle. All right, now we're on 66. Secant 4x equals 2, which you didn't have to do. All right, so I'm doing 66. Says secant 4x equals 2. All right, so I'm going to change that to cosine 4x is 1/2. Cosine u is 1/2. And so cosine's positive here and here. So u is pi over 3 and 5 pi over 3 plus 2 pi k, where k is any integer. And as Zayna pointed out, technically I should add that to both of them. Okay? Now I'm going to take u back out and put 4x in. And then I'm going to divide by 4 or multiply by 1/4. This will give me pi over 12, 5 pi over 12, plus pi over 2k. If you were going to do all real solutions, how many times would you go around here? Let's do it. I would, with my u, I would go around 4 times. Pi over 3, 5 pi over 3 catches the first 2 times that cosine equals 1/2. Do y'all see what we're doing? Okay. But this period is very fast. So I'm going to add 2 pi, which is 6 pi over 3. That takes me to 7 pi over 3 and 11 pi over 3. That's my first cycle, my second cycle. I'm going to get my third and fourth cycle. That's going to give me 13 pi over 3 and 17 pi over 3. And then when I add to that, if you could read my writing, that gives you 19 pi over 3. And add to that gives you 23 pi over 3. But what are you going to do with all of these? Divide by 4. So I'm not going to list them all in interest of time, but I start with pi over 12 and write my list. And I end with 23 pi over 12, which barely squishes in right before 2 pi. So this time you would have 8 answers. So if we turned on our calculator and looked at this graph, quite literally, if we looked at secant x equals 2, we would see this. Secant x looks like this. And if the period of it is, the period of this is pi over 2, so by the time I get out to 2 pi, I would have gone through 4 of them, which I don't know if I've drawn enough. But y'all see all the times in there it would equal 2. 1, 2, 3, 4, 5, 6, 7. There'd be another one out there. Okay? Question?
How do you figure out how many?
You don't. I don't know. When I get to a problem, I just got to work the problem. There's not a set. The set thing that you do all the time is you're very aware of the period and what you're doing. Like, for instance, here, I was looking at where there's a lot of things I could put in this box, girls. Okay? If I put 1 in that box, there's going to be less answers than if I put in 1/2 in that box. There's not a set number of answers. I just think every time cosine's 1/2, which happens twice in the first cycle. And then because of the 4x, I know the cycle's way shortens. So I better go around 4 complete times. 1, 2, 3, 4. And then I divide it all by 4. But it all depends on what I set it equal to. It could have no solution. It could have 4 solutions. It could have 8 solutions. It could have 3 solutions. That, like I said a few minutes ago, and it may not hit home until the thought occurs to you, is right now people are always like, well, how will I know how many I have? There's no rule. You've got to know what you're doing. Okay?
Would you ever do a problem on the test with more than 8 solutions? Do you think?
That's a great question. At some point, that's such a good question. That leads another thing in the AP calculus right now. We actually learn in calculus to add up an infinite number of rectangles, which I won't get into because that sounds impossible, which is super cool. But in order to make sure they've got the theory down, the AP only asks for 3 or 4. And they can tell from that 3 or 4 if the students know what they're doing. So why ask for 40? So that's a good point. I mean, at some point, I'm just like wasting your time when I can get away with a 3x or a 4x to see if you know what you're doing. So I'm not going to make it have some crazy like 12x period of pi over 6 where you just got to sit there and list answers. But I will go out at least 3, maybe 4.
Okay. So like for this December 17th test,
No. No, it's just, at that point it's pointless. Now, I'm not saying I wouldn't here, because here you just find everything that happens in one cycle, and then you divide. But no, you're not going to have to just sit there and add and list. I want you doing something more important. Okay, so moving on. The last one on this one is tangent x over 3. Did I finish this? Oh no, 67, the one y'all did. 67 is cosine of x over 2 is equal to root 2 over 2. Cosine u is root 2 over 2. That happens when u is pi over 4, and again at 7 pi over 4, plus 2 pi k. I'm going to go ahead and add the period of that. Then I'm going to put in x over 2 and multiply by 2. And I get pi over 2 and 7 pi over 2 plus pi k, where k is any integer. I don't know what they said.
We need 4.
Oh, yeah, I divided by 2. You should multiply by 2. Thank you. And I think that's what they had in the back, isn't it? And like Zana said, they listed them separately. I don't know where I got in the habit of doing that. I need to ask Mr. Hill what he does. Everybody okay with that? Now what that does is you've got this cosine graph with a really long, lazy period of 4 pi k, of 4 pi. So you grab 2 times that it happens, and then it goes backwards and forwards, always and forever, and you're landing on every answer in the whole wide world. All right, now let's do the 0 to 2 pi thing. All right, so I would let u be root 2 over, I'd be looking at where cosine of u is root 2 over 2. I would say u is pi over 4, 7 pi over 4. And you might want to list one more, but I'm not worried about this list. Do y'all see I don't have 2x, I have x over 2. The period of this one is 4 pi. Not much is going to happen here. It's way different if the period's pi over 4 as opposed to 4 pi. Do y'all see I'm not, like, okay, here's what I'm saying. Is with 2x, I said go around twice. With 3x, go out 3 times. With x over 2, I only need to go around halfway. I guess that's what I'm trying to say. That makes sense? Okay? So I've really listed too many already, but you'll find out you can scratch one out. Okay? When the period's real long and lazy, you don't have a lot of answers. When I put x over 2 back in, I get x is equal to pi over 2, and the next one would be 7 pi over 2. Does that fall between 0 and 2 pi? I don't need that one. It would only be that one. Because this graph doesn't finish itself until it gets to 4 pi. Okay? All right, now let's look at number 68. And this is the first one of these that I've given you, so we need to talk about this. 68 is tan x over 3 equals 1. All right, pay close attention, girls. Why am I like, if you've got it, and a lot of y'all are just sitting there like, you got a lot better than I thought you had it, because it seems like that you're clocking along with me just fine. So that's awesome. But why am I being really adamant right now about watch? Because all of a sudden we have what? A different period, right? We have tangent, which only has a period of pi. You want to tell me if your birthday is February 29th, I need to know that, and it only happens every 4 years. You got to be aware of the period of the graphs that you have, okay? So I'm going to do tan u is 1. That happens when u is pi over 4 and 5 pi over 4 plus pi k. I'm going to take u out. Are y'all okay with that? I'm going to take u out and put x over 3 in. So I get x is 3 pi over 4 and 15 pi over 4 plus 3 pi k. They only have this answer. Before I tell you why, do you might know why? Tangent's such a weird beast.
Can you put the first thing as the answer also?
Oh yes, yeah. I would count this answer correct too. I would count the red answer. That is right. You will get that right. Grace?
Well, that satisfies it, because like 3 pi over 4 plus 3 pi k is equal to 15 pi.
Yeah, but what would, oh, yeah, so you might notice that satisfies it, because this turns into 12 pi, over 4. And you would hit 15 going around. What's the period of tangent? Pi. And why did I just, in a picture, this is what I just did. You know how I'm big on pictures, all right? This is your first tan graph. This is your second tan graph. This is 2 pi. Not exactly out there. This is actually 3 pi over 2. And this is pi over 2. So did y'all see, if I'm looking for it to equal 1, I picked it up here. And really, I'd gone past pi when I picked up that second one. I think you're going to like this picture better, though. Look what happens with tangent because of the first and third quadrant. Girls, what if I have 60-degree angles? I know these are 45s. I'm not worried about that right now. I just want to talk. If these are 60-degree angles, I basically have to list both of them. Let me pause for a minute. I'm thinking too fast and not telling you what I'm thinking. That's where sine would be positive, right? Cosine would be positive here and here in the green. But where would tangent be positive? And where would tangent be negative? How many radians are those apart? So what just happened? As I was at pi over 4, when I rotated pi, I'd already picked this one up. I didn't need to list it again. When I wrote this down, I was already going to pick up 5 pi over 4. Do y'all see what I mean? Period of tangent's pi. But be careful, kind of just be aware, all right? All right, now let me go back to whoever asked if I would take that answer. Mr. Hill and I haven't created the test yet, and a lot of times we'll throw in some multiple choice. So I wouldn't put both of these in the multiple choice. That wouldn't be fair, okay? But if you got this one and you didn't see it in the multiple choice anywhere, then that probably means you could condense it into something like this that you would recognize. I will not give you both of these because they're both right.
But if we let's say it's an open answer and you write it first, what's that?
Perfectly fine. Yeah. All right, so let's move on to the calculator. And we're also going to write on your memo page in a minute, so make sure you have that where you can find it. All right, so we have y equals, did I give you 73? Did I give you 73?
Yes.
All right, 2 cosine x minus sine x. And it's already equal to 0. If it was not equal to 0, I would get it equal to 0. Okay? All right, and then I'm going to check my window 0 to 2 pi, and I'm going to graph it. I will not help you set your window on the day of the test. I've got mine set from 0 to 2 pi. There's times I want to change my y min and max if I can't see it very good. See what? Well, I can see it pretty good. So then I'm going to go second, calc. I'm going to go to intersect. And I'm going to move back here. Enter. And I'm going to move to the right of it. Don't go past that little hump. Enter. Enter. It seems to be frozen. Oh, I'm sorry. I didn't intersect. Second calc 0. Sorry. All right, so I need to be to the left of it, to the right of it, and then enter. All right, so I get 1.107. And I always want 3 decimal places. Now let me show you this. I kind of did it the other day. It aggravates me to sit down and hold the arrow key down. So when I go to second calc 0 again, second calc 0, I can actually enter a number like 3 and hit enter, and it'll take me over there. All right, so let me start over. All right, it's really nice if you have a big graph. Second calc 0. Let's say I wanted to be a little closer, so I'm kind of starting over. Suppose I want to be at 3.5.
Could you just do second calc zeros and then you just type it in?
All right, I'm going to do it again. Second calc 0. You see where it says left bound? Right now, I'm just doing this. I'm going 3.5. Like I'm actually, with my fingers, I would be pushing those keys. And hit enter. And then I can put in something that I know is just past it, which would be 5. So right bound, I'm going to put in 5. As soon as I hit the 5 key, it knows I'm taking control. And then enter. And I get 4.24, say, 4.24. I would take 248 or 249. Okay? All right, now moving on, because I think that's all you had for homework. Okay? I didn't do every problem, but you could check 75 in the back. All right, now, all right, so we are going to write something new on your memo page. So everybody get out your memo page, and everybody be quiet. A lot's going to happen in 7 minutes, all right? All right, one thing you're going to add is the negative angle identities. Which I really can't believe I haven't added already. I keep writing a note to myself. Girls, please don't talk. Please be careful as you're writing down. What do you notice about cosine negative x? Okay, lady, it doesn't have a negative in front of it. Girls, I'm not allowed to, nor am I factoring out a negative. I'm just telling you a math fact. And I'm going to explain it to you. Okay, now I want you to do something really quickly on your calculators. I don't care what mode you're in. Or look at your neighbors, but do this really quickly. Okay? And by the way, this won't show up on your next memo quiz, maybe the next one. Alright? Type in sine of negative 150. Sine of negative 150. And then negative sine of 150. Did you get the exact same thing?
Yes.
All right, that'll happen with tangent also. Now I want y'all to do this. Clear it out. And put in cosine of 150 and cosine of negative 150.
Interesting.
All right, I didn't really do that very well. Clear it out. What I really wanted you to notice was this. Put in sine of negative 150 and sine of 150. Are they the same or are they opposites? That's what that statement's telling you. Okay, they're opposites. They're not the same. But what happened with cosine? All right, let's talk about y. And again, girls, no talking just for the next few minutes, okay? Sine looks like this. You're not writing this in your memo page, you're just listening to me. Tangent looks like this. Cosine, you'll learn as you go through pre-cal and calculus. It's kind of like the weird animal in the bunch. It's going to always do something different. And that's because it's actually an even graph, whereas the other two are odd. You should remember from algebra somewhat, an odd graph is symmetric to the origin. This dot pops through the origin and comes out the other side like a mirror. This side comes through the origin over here. This dot goes through the origin and lands over here. Do y'all see how this tangent graph is odd? Look at your cosine graph. Y'all remember even is symmetric to the y-axis. This doesn't go through the origin. Do y'all see how these points are going over here? It's symmetric to the y-axis. Sine and tangent are odd. Cosine is even. All right, let's look at y. All students take calculus. Okay? This is for sine. Please, I want to make sure everybody's watching. This is for sine. Okay? If I take 100 degrees, it lands here. Negative 100 degrees lands here. If I take 30 degrees, it lands here. Negative 30 degrees lands here. What do you notice about the signs of an angle and its opposite? They're different, aren't they? So that's why I said this. Does that make sense? Just my way of telling you f of negative x equals negative f of x, if you sort of remember that lingo. That's odd. Tangent goes like this. This is tangent. All students take calculus. This is for tan. If I go in this quadrant and then I go back the other way the same distance, do I get the same answer or do I get opposite answers? Cosine. All students take calculus. Do you see it doesn't matter which way you go? Look at the graph, girls. Look at the graph. In yellow. On cosine, does it matter if I go this way to get my value or this way to get my value? Doesn't matter. So in the future, if someone asks you for the cosine of negative 120 and you don't feel like doing it, you could just find what? The cosine of 120. Okay? Now, we're not going to add these to your memo page today, okay? But you're going to use them in homework. So don't write this on your memo page. I'm just going to write it on the board so I have it. Sine A plus B What about the sine of 30 plus 45? Do y'all think it's okay for me to say the sine of 30 plus the sine of 45? Oh, good. Okay, so Zane is going, no, don't do that. It's highly unlikely that I could actually distribute a math function like this. Okay? You will not get it right. If we had time to do it on our calculator, you would miss it. Okay? So it does this weird pattern, which I'll prove to you why this works, because you should go, how in the world would anybody know this would work? Okay? But you get to like just put pieces of a puzzle together for homework. It goes sine A, cosine B, plus cosine A, sine B. So when you see in your homework sine of 75 degrees, you'll think of two things that you know, 30 and 45. Then I'll type the patterns into your homework, so you can just keep looking at those till they're on your memo page. This is A and this is B. I'm going to go sine A cosine B plus cosine A sine B.
For the first one, is it sine A plus cosine? Wait.
It's sine A cosine B
Okay.
plus cosine A sine B.
So it's like cosine 30, sine 45.
Thanks. Sine A cosine B plus cosine A sine B. This gives me 1/2 root 2 over 2, root 3 over 2, and root 2 over 2. My final answer to this, if you could read my writing, hang on just a minute, girls, I'm hurrying. That's going to give you square root of 2 over 4 plus square root of 6, and they're both over 4. We obviously don't have time to try this, but at home you could type in sine of 75 degrees, and what would happen if you type that in? You get the same answer. Okay, so I'll give you a few to try. All right? Bye, girls.
Feel better.
Thank you. Sorry I went long.
Thank you.
Bye. December